A second lesson from this module, it's about solving a quadratic equation by graphing. So all I need you to know from this lesson is how will be the graphs for the quadratic functions in the coordinate plane. Now, as you can see here, miss, from the graph, I have three cases. In the first situation, you can notice easily that there is no intersection between the parabola, the function, in the coordinate plane and the x-axis. Means solution for a quadratic functions, it means intersection with the x-axis, not y-axis. The roots, the solutions, the values of x, all of these are actually names for a solution of a quadratic equations. Now, if you remember, we said in the class, what's the difference between equations and functions? That, equations, I need them for solutions. If I ask you to solve, you need an equation. If I ask you to graph, you need actually functions. Functions, I need them to graph. Now, the difference that if you want a function, you will replace 0, which is actually in one side of the equation, by f(x) or by y. If you want, an equation from a function, all you have to do is put instead of y or f(x) 0. This means that are using, or you are depending on the intersection of the parabola with the x-axis. Here, as you can see, there is no intersection between the parabola and, the x-axis. No intersection. There is actually distance between them. Now, what about if the parabola was downward, even if it was small, like, for example, like this? Does this mean there is no intersection? No, of course, there is an intersection, because actually all of the parabolas are functions that have real numbers, all of the real numbers as a domain. So look, it must be, it's not limited. There must be an arrows for both sides, that it goes to infinity from both sides. But for this situation, the graph, I just graph it here, the parabola, I graph it. There is intersection for sure with the x-axis, but here, no. For this graph, exactly for this graph, there is no intersection between the graph and the x-axis. So easily there is no solution. As you can see here, there is no solution. While in the other one, there is solution. As you can see here, it's the vertex. When I have only one solution, for most of the times, usually we can say it's the vertex for the parabola. Okay, now as you can see here, x is equal to 3. This is the axis of symmetry equation. So the solution is one point, as you can see here, which is x is equal to 3. It's not a point x and y. No, it's only x value. So the solution is one x value, which is x is equal to 3. The last situation, as you can see here, that when you have two solutions, as you can see here. Now, so when I have two solutions, then I have two solutions, two root, two intersection of the axis of symmetry, of the parabola with the x-axis. Now, so as you can see here, maximum number of solution for a quadratic function is 2. Minimum number of solution for a quadratic function is 0. We may have no solution for this quadratic function. Okay, we may have no solution. According to the graphs, it means no solution. It means no intersection with the x-axis. But as you can see here, for example, we can notice that there is two solutions, right? So this is solution, this is the first solution, and this is the second solution. X is equal to 0, and x is equal to, 2. So we can notice that this is the end of the equation, this is the end of the lesson. All I need you to know that there are three, let's say, three types, three situations. One of them when I have the minimum number of solutions for parabolas, which is 0, and one which I have maximum number of solutions